So we're going to begin with an easy example. Our function is given to us as f of x is equal to 3x plus 4. And we are told to find f of 5, f of negative 2, and f of 3. What I want you to do as we get started is to make yourself a note, and I'm going to do it down here since I have some room. We're going to make ourselves a note that whatever is inside the parentheses that is going to get plugged in for x. Okay, so whatever is inside the parentheses, we're going to always plug in for x. And if you can remember that, then you will know always how to evaluate these functions. So I'm going to begin with f of 5, which is the first example. And again, whatever's inside the parentheses is going to get substituted in for x. So up here in my function, in place of that x, I'm going to substitute in, and I'm going to leave it in parentheses, the 5. So I'm going to rewrite it first. So I have 3 times 5 plus 4. Remember, your order of operations says to multiply first. So 3 times 5 is 15, plus 4 is 19. For the second problem, we have f of negative 2. Again, whatever is in parentheses is going to be substituted in for this x. So I'm going to be putting in a negative 2 for that x. So I have 3 times negative 2 plus 4. So 3 times negative 2 is negative 6. We're going to add 4 to it, and we'll come up with negative 2. And then for our last example, again, whatever is in parentheses is going to substitute in for the x. So in place of this x, we're going to be putting a 3 this time. So we're going to have 3 times 3 plus 4, just rewriting. Multiplication first, so 3 times 3 is 9, plus 4 is going to give me 13. And again, that's a fairly easy example just so you can see the process of what needs to happen. Let's try another one. This time we have g of x is equal to x squared plus 3x plus 2. And our first problem says that we want to do g of negative 2. Again, whatever is in the parentheses is going to go in for the x, and it goes in for all x's. So in place of this x, I'm going to be putting a negative 2. And also in place of this x, I'm going to be putting a negative 2. So let's begin by rewriting our problem. So I have negative 2, and that is squared, plus 3 times negative 2, plus 2. Again, order of operations tells you to start with your powers and then move to multiplication. So first I'm going to do negative 2 squared. If you're using your calculator, be sure that you put the negative 2 in a set of parentheses. Negative 2 times negative 2 is positive 4. I'm going to go ahead and I'm going to do my multiplication next. So 3 times negative 2 is going to give me negative 6. And then finally, we'll do the addition and subtraction. So 4 plus negative 6 plus 2 is going to give me 0. And use your calculator as much as you need to evaluate these functions. All right, let's move on to the next one. The next one says find g of negative 1. So again, wherever there's an x, we're going to substitute in a negative 1. Keep it in parentheses. So we'll rewrite first. So I have negative 1, that part's squared, plus 3 times negative 1, plus 2. We do our powers first. So negative 1 squared is going to become a positive 1. Then we'll do our multiplication. So 3 times negative 1 is negative 3. And then finally we'll do our addition and subtraction. So 1 plus negative 3 plus 2 is also equal to 0. The last problem asks us to find g of 0. So where there's an x, we're going to place a 0 this time. And we'll rewrite to begin with. So we have 0, that is squared, plus 3 times 0, plus 2. Again, exponents, powers first, so 0 squared is still 0. Multiplication next, 3 times 0 is 0. And then finally addition and subtraction. So 0 plus 0 plus 2 is going to equal 2. So that's a problem where you're plugging in your x value in more than one place. The last problem I want to show you is one that has a fraction. So our function is h of x is equal to 2/5 x minus 9. And the first problem is h of 5. So again, wherever there is a x, we're going to this time plug in a 5. So I'm going to rewrite it first. So I have my fraction, 2/5. I'm going to be multiplying by 5, and then I'm going to subtract 9. Now again, feel free to use your calculator as much as you need to here, but if you choose to do it by hand, I want to remind you that if you're multiplying 2/5 times 5, remember that a whole number like the 5 that doesn't seem to have a denominator is technically over 1. And when you multiply fractions, you don't need a common denominator. You just need to multiply the top parts together and the bottom parts together. So I would start by doing 2 times 5, which is going to be 10. And then I would do 5 times 1, which is going to be 5. 10 divided by 5 is going to give me 2. So I'm going to have 2, and then I still have the minus 9 on the end, which is going to give me a negative 7. Plugging in a negative 5 is not going to be much different. We'll come to our function, and in place of the x, we'll put a negative 5. So I have 2 over 5 times negative 5 minus 9. In terms of my multiplication, if I'm multiplying by negative 5, the only thing that's going to change is that when I multiply 2 times negative 5, I'm going to get negative 10. And negative 10 divided by 5 is going to be negative 2. So we'll have negative 2 minus 9, which is going to be negative 11. And then our last one, h of 0. So we're going to plug a 0 in for the x. So we'll have 2 over 5 times 0 minus 9. 2 over 5 times 0 is going to be 0. Minus 9 is going to give me negative 9 as an answer. And so now you've seen how we evaluate functions. I want to point out to you that our typical notation is an f of x, but it doesn't really matter what letter they use. We can see here that they used an h, and in the last example they used a g. The notation of a letter next to the x, regardless of whether that letter is an f, a g, a h, or something else, indicates that we're dealing with a function.